Now we will discuss the excitation table of different flip-flops. Now what is the excitation table? Excitation table means in order to get a particular output, what should be the input applied to the flip-flop. Now here first let us consider an SR flip-flop. For an SR flip-flop, first let us consider what is the truth table of SR flip-flop. When S0, R0, there is no change in the output. When S0, R1, it will be reset to 0. When S1, R0, it is set to 1. And S equal to 1, R equal to 1, it is not, the output is not defined. Now, let us now create the excitation table for SR flip-flop. Now, assume that the present state is 0 and the next state is 0. Now, for the next state to be the same as the present state, say here in this case it is 0, what should be the value of the input? There are different possibilities. That is, when S equal to 0, R is equal to 0, as you can see the next state is the same as the present state, whatever be the value of the present state. Again, in this particular case, output present state is 0 and the next state output is 0. Okay, that is, again we can, another possible combination is S is equal to 0, R is equal to 1. For this combination, whatever be the value of the present state, the next state will be 0. So here we can say there are two possibilities, S0, R0. Another possibility is S0, R1. That is, R can take any of the values 0 or 1. So it can be denoted as S0, R equal to X. Don't care. That is, it can take either 0 or 1. Again, similarly, in order to make a transition from the present state 0 to the next state 1, the possible values of the input are, one combination is 1, 0. Only that combination is possible. Again, in order to make a transition from the present state 1, next state to 0 is 0, 1. Again, from 1 to 1, it is either it can be 0, 0 or it can be 1, 0. So, since S can take any of the value, it is X0. Next, we will discuss the excitation table of JK flip-flop. This is the truth table. Now, from the truth table, we can find the excitation table. So, in order to make a transition from 0 to 0, the possible values of J and K are, one is 0, 0 and another possibility is 0, 1. This K can take any value, that is 0, X. Again, in order to make a transition from 0 to 1, here the possibilities are either it is 1, 0 or the toggle condition 1, 1. So, it is 1X. Again, in order to make a transition from 1 to 0, it is X1. Again, from 1 to 1, it can be either 0, 0 or it can be 1, 0, that is X0. Again, next we will see the excitation table for D flip-flop. As from the truth table of D flip-flop, it is clear that whatever be the value of D input, the output is the same as the value of D input. The next state is same as the input here. So, here in order to make a transition from 0 to 0, the input applied to be 0. Here we need to look at only at the value of the output, because in D flip-flop it just follows, the output is just the input itself. So, in order to get the next state equal to 0, the input applied should be 0. In order to get the next state equal to 1, the input applied should be 1, whatever be the present state combinations here. Again, in case of T flip-flop, there are two conditions. When the value of toggle input or T is equal to 0, there is no change in the next state. And when the value of T is equal to 1, the output toggles. So, here we can say, in this case, in order to make a transition from 0 to 0, T input should be 0, because the next state is same as the present state. When in order to make a transition from 0 to 1, T input should be 1. Here you can see it toggles, the output toggles here. From 1 to 0, it is again T input is equal to 1, output toggles. Again, from 1 to 1, the output remains the same, so T input is equal to 0. So, this all are about the excitation table of the different